and this is adding and subtracting matrices. This should look familiar, as we've done it before. Write down the definition of a matrix. A matrix is a rectangular arrangement of numbers in rows and columns. We have an example here of a 2 by 2 matrix. You always name a matrix rows first, then columns. We have 2 rows. Rows go horizontally, columns go vertically. And when I read out a matrix to you, you always read by rows. So you would read this as A, B, C, D. Okay? Down here we have a 2 by 3 matrix. We're going to add 2 by 3s. You can only add or subtract matrices that have the same dimensions. You can only add a 2 by 3 matrix to another 2 by 3 matrix. You can't add a 2 by 3 and a 3 by 2. Okay? Question? So all I do here...
Wait, what did you say?
You can only add 2 matrices that have the same dimensions. You can only add a 2 by 3 to a 2 by 3. You cannot add a 2 by 3 to a 3 by 2.
What about subtracting?
Same thing. Add or subtract.
So these two are 3 by 2.
These are 2 by 3s. 2 rows, 3 columns.
Okay.
Okay? Rows are horizontal, columns are vertical. So all you do to add these is add the corresponding entries. Add 1 and 3 to get 4. Negative 2 plus 9 is 7. 0 plus negative 3, negative 3. 3 plus negative 9, negative 6. Negative 5 plus 6, 1. And 7 plus 12, 19. Good?
What do you mean 2 times 2 into the rows and columns?
That's a 2 by 2. It's not 2 times 2.
Okay.
2 rows by 2 columns. It's a big X, representing dimensions. Okay?
So it tells you to state the dimension of a matrix. For the example, you put 2 by 2.
For this
No,
example,
the one above it. The one
yeah,
above it.
that's a 2 by 2, and this would be a 2
2 by 3.
2 by 3.
Alright.
Okay?
Wait, why would the second one be a 2 by 3?
Because
There's 2 rows,
3 columns.
3 columns. Remember, columns are vertical. Okay?
Okay.
Rows are horizontal. Write down
I think.
the definition of a 0 matrix. That's pretty simple. All your entries have to be 0. Whenever you add a 0 matrix to any other matrix, your result is the original matrix. Okay, so write down this example. 0 matrix, 0, 0, 0, 0. This is a 2 by 2 0 matrix. We add this 2 by 2 to the 0 matrix. We know 1, 2, 5, negative 7, which is representing the identity.
But what's representing the identity?
That whole bottom row,
Oh,
the addition of those 2 matrices.
oh, it's just representing the rule for 0 matrix. Okay.
Okay? Alright, next example is subtraction. Zach, you were asking about this. You can only add and subtract matrices with the same dimensions. What type of matrix is this?
2 by
2 by 3?
2 by 3.
2 by 3. You end up with a 2 by 3. So what is 3 minus 1?
2.
2. 2 minus 4?
Negative 2.
4 minus 3?
1.
Negative 1 minus a negative 2?
1.
1.
1. 4 minus 2?
2.
2.
And 0 minus 4?
Negative 4.
Question?
What's the point?
You did the indicator.
Next example, solving a matrix equation. This big X here is representing a matrix. Alright, so we have matrix X minus 1, 1, 3, 2. So we solve this just like we were solving an equation.
So they don't put it in the matrices box, they just give you an X and you have to know that it's a matrix?
Yeah, if you know, if it's a capital X, that's representing a matrix. Or if it says solve a matrix equation, then that's what this one would say. It would say solve a matrix equation, and you had to find a matrix.
Alright, so you pretty much just find the difference for this one?
Yeah. Or the
It's a subtraction?
Yes. Well, we'd solve it just like we would solve any equation. If we have X minus a number equals a number, how do you solve that equation? You add this number to both sides. So I'm going to add this matrix to both sides. Now I end up with X equals 1,
Alright, yeah.
2, 11, 11. Okay?
And your answer would be the matrix.
Yes. You are looking for a matrix there.
Whoa, you go back.
Yeah.
Okay.
All right. Next example. Are the following matrices equal? All you have to do is
Yes.
compare the corresponding entries.
Yeah, they are.
Yes is the answer, because 0.75 negative is the same thing as 3/4. All of those entries are the same from this matrix to the next. Okay?
And you have to make sure that all of them match up, right?
Every single one.
8 minutes.
And here, this is our last example. If you have two matrices, these are both 2 by 2 matrices. Okay, that first entry is 2x minus 5, 4, 3, and 3y plus 12. So this is one entry right here. This is one entry. Same thing here, y plus 18. So to solve for x and y, very simple. 2x minus 5 must equal 25. Okay? And to solve for y, 3y plus 12 must equal y plus 18. And then solve from there. And you should get x to be 15 and y to be 3. Question.
How would you put that in the answer in matrices?
You don't put this in the matrix. All I'm looking for is a variable, x and y.
Oh,
In that previous example, we were looking for matrix x. Here, I'm just trying to figure out two variables.